Myself Archana J from Sri Venkateshwara Engineering of Bengaluru, Department of Computer Science and Engineering and Data Science. Today, my topic is vector calculus. In that, there are many subtopics like introduction to vector calculus, scalar field, applications and scalar field, vectors, vector field, gradient, divergence, curl, solenoidal vector fields, irrotational vector fields, relationships and significance and applications of vector fields. The first topic is introduction to vector calculus. Vector calculus is a powerful phenomena tool that has numerous applications in the computer science, engineering, and physics. It provides a framework for analyzing and understanding the behavior of the vector fields, which are essential for describing the various physical phenomena such as electromagnetic field, fluid dynamics, and gravitational field. This introductory section will lay the foundation of concepts and techniques covered in the following section, setting the stage for a deeper exploration of these important branches of mathematics. Scalar field. A scalar field is a function that analyzes a scalar value to every point in a given space. This value can represent various physical quantities such as temperature, pressure, or potential energy. Applications on scalar field. Scalar field has numerous applications in various fields including physics, engineering, and computer science. Example includes temperature distributions, potential energy land space, and density maps in computational biology. Vectors. Vectors are the mathematical objects that represent both magnitude and direction. They are essential for describing and analyzing the physical quantities that have both size and direction, such as force, velocity, and electric fields. Vector fields. A vector field is a function that analyzes the vector to every point in a given space. Vector field can be used in the modern and analyze a wide range of phenomena including electromagnetic fields, fluid flows, and gravitational fields. Gradient. The gradient or the scalar field is a vector field that points in a direction of maximum rate change of the scalar field. It represents the direction and rate of change of scalar field at a given point, and it has a numerous application in the optimization, physics, and computer science. Divergence. The divergence of the vector field is a scalar field that represents the density of the outward flux of the vector field from a influential volume around a given point. It is used to analyze the source and sinks of the vector field, which applications in the fluid dynamics, electromagnetism, and astrophysics. Curl. The curl of the vector field is a vector field that describes the rotation of twisting the field. It presents the density of the circulation of the vector field around a given point, and it is used to analyze the rotational aspects of the vector field, which applications in fluid dynamics, electromagnetism, and general relativity. Solenoidal vector field. Solenoidal vector field are these are which zero divergence means that the net flux of the vector field out of the infinitial volume is zero. These fluid representation physical quantities that exhibits the circular or rotational behavior such as magnetic field and viscosity in fluid dynamics. Irrotational vector field. Irrotational vector fields are these which zero curl means that the circulation of the vector field around the closed path is zero. These fields represent the physical quantity that exhibit the potential-like behavior such as conservative force fields and velocity fields in the potential flow theory. Relationships and significance. The concepts of solenoidal and irrotational vector fields are closely linked to the fundamental theorem of vector calculus, which states that every vector field can be uniquely decomposed into a solenoidal part and an irrotational part. This decomposition has important implication in the fields like electromagnetism, fluid mechanics, and general relativity. Applications of vector calculus: fluid dynamics, computer graphics, electromagnetism. Fluid dynamics. A vector calculus is the foundation for the fluid dynamics modeling and numerical stimulation for the fluid flows, enabling the analyzing of the complex phenomena such as turbulence, formation, and boundary layer effects. Computer graphics. Vector calculus is essential for modeling and manipulating the 3D objects, rendering realistic lighting and shading, and stimulating the fluid dynamics in a computer graphics and application. Electromagnetism. Vector fields are used to describe the analyzing the electric and magnetic fields, with the concept like gradient, divergence, and curl being critical for understanding the phenomena like Maxwell's equation and electromagnetic waves. Thank you. Thank you for watching my video. Like, share, and subscribe.